For years, interacting with top-tier artificial intelligence meant constantly feeding it instructions. A model would generate an answer, then wait for you to tell it what to do next. It required continuous human supervision to inch its way through a complex task. Claude Fable 5 and Mythos 5 represent a shift towards stamina. These models possess the endurance to maintain complex workflows far longer than any previous release. They engineered the model with what is known as long-horizon autonomy. Once given a prompt, it can maintain focus over millions of tokens, strategize its next moves, and crucially, identify and correct its own errors over extended periods without a human ever stepping in. Crossing the threshold from a reactive assistant to an autonomous agent scales up the size and type of real-world problems the system can actually solve. When the payment processor Stripe tested Fable 5, they pointed it at a massive 50 million-line codebase. The AI performed a codebase-wide migration autonomously, a project that would have required an entire engineering team over 2 months to complete by hand was finished in a single day. Its reasoning extends beyond text. Fable 5 managed to play and complete the video game Pokémon Fire Red entirely on its own, relying on nothing but raw visual screenshots and completely discarding the complex helper harnesses that earlier models needed. It derived planetary orbits from the first principles of physics to predict solar eclipses, and even coded an entire 3D CAD editor from scratch inside a web browser. To execute these multi-step workflows, the model accesses persistent file-based memory, taking its own notes and referring back to them to stay on track during long-running tasks. But that exact capability presents an obvious risk. If an intelligence can autonomously map and rewrite a 50 million-line corporate codebase, it theoretically possesses the baseline skills to autonomously map and compromise a nation's critical digital infrastructure. An unguided problem-solving engine of this caliber poses a severe security risk, making it far too dangerous to deploy to the public without building an entirely new class of digital containment. Anthropic's solution to the dangers of autonomy was to build a real-time checkpoint system directly on top of the Fable 5 engine. They deployed dedicated AI systems called safety classifiers. These active monitors evaluate user inputs to detect jailbreak attempts, bioweapons, or cyber threats. But rather than shutting down the entire system, Anthropic engineered a fail-soft protocol. They route around the danger. When a query gets flagged by the classifiers, the system doesn't issue a hard refusal. Instead, it seamlessly hands the prompt off to an older, highly capable, but much safer model, Claude Opus 4.8. This layered architecture allowed Anthropic to maintain a smooth, frictionless experience for commercial users, while silently executing severe, real-time threat mitigation in the background. Which raises a crucial question: what actually happens when those safety classifiers are intentionally turned off? For a select group of cleared researchers, Anthropic answers that question with Claude Mythos 5. Delivered through the Project Glasswing Trusted Access program, Mythos 5 is the exact same underlying engine, but with the safeguards completely lifted. Unrestricted, the model acts as a highly capable research scientist in the biological frontier, accelerating complex drug design workflows nearly tenfold, completely without human assistance. In tests predicting the traits of adeno-associated viral shells, Mythos 5 managed to outperform dedicated protein language models, relying on pure biological reasoning to understand viral assembly. Over a week of largely autonomous work, it designed and trained custom machine learning models to analyze single-cell genomics. The model it produced easily surpassed the performance of one recently published in the journal Science, despite being 100 times smaller. Mythos 5 highlights a deeply unsettling reality in biology. The exact same autonomous intelligence required to cure disease and accelerate therapeutics is identical to the intelligence required to engineer catastrophic biological harm. AI has crossed into the category of dual-use technology, carrying societal stakes equivalent to advanced cryptography or nuclear physics. Recognizing this, Anthropic implemented a mandatory 30-day data retention policy for business customers, a security measure designed specifically to monitor the network and study novel cyber attacks. The system worked. The real-time fail-safe architecture held up, and external red team organizations failed to crack the long-form safety net. But the sheer existence of the unrestricted engines sitting just beneath those classifiers terrified authorities. Just days after the models were launched, the United States government intervened. issuing an immediate export control directive that suspended all access to both Fable 5 and Mythos 5. The government didn't step in because the safety classifiers failed or the digital net broke. They stepped in because the raw underlying potential of the engine itself was deemed simply too high risk to exist in the public domain. Human engineering successfully built a truly autonomous digital intelligence. But our societal and governmental frameworks were utterly unprepared for the reality of turning it on.